All right, you are welcome to the class again. Now let's solve this problem. Now, how do we solve this problem? Now, we're going to be applying one of the laws of indices here. A raised to the power of x plus y is the same thing as a raised to the power of x times a raised to the power of y. So that is what I'm going to be applying here. The base here is 1 over 2, and the power is x plus 1. So I'm going to be splitting it this way. Now let's do that to this. I have 1 over 2 raised to the power of x times 1 over 2 raised to the power of 1 plus 1 over 2 raised to the power of x equals to 3 over 8. Can you see that? This is the only thing that is changing. All right, I can say let's p be equals to 1 over 2. So if p is 1 over 2, so that means this equation turns to p raised to the power of x, okay, times 1 over 2 plus p raised to the power of x equals to 3 over 8. All right? So here now, this is 1 over 2 p raised to the power of x plus p raised to the power of x equals to 3 over 8. Because this times this is going to give you this. Now, we have half p and half p raised to the power of 2 plus 1 p raised to the power of x, rather, half p raised to the power of x plus p raised to the power of x. When you add it together, it's going to give you 1/2 p raised to the power of x. So 1/2 p raised to the power of x equals to 3 over 8. Do you get that? This is 1 p raised to the power of x. This one is half of it. So it's going to be 1/2. So this 1/2 can be expressed as 3 over 2. 2 times 1, 2 plus 1, 3 over 2. So this can turn to 3 over 2. All right, so here you divide both sides by the coefficient of p raised to the power of x. So we have p raised to the power of x equals to 3 over 8 divided by 3 over 2. All right, so when you divide this one by 3 over 2, you have this. Divide this one by 3 over 2, so you still have it there. So now we have p raised to the power of x equals to 3 over 8 times 2 over 3. So this sign changes to multiplication. So this comes up and this one comes and the reciprocal of that. So now this cancels this. 2 goes there 1, 2 goes there 4. We have p raised to the power of x equals to 1 over 4. And don't forget, p is 1 over 2. So this is 1 over 2 raised to the power of x equals to, now this can be expressed as 1 over 2 raised to the power of 2. Okay, so the bases are equal, so you can equate the powers. So we now say therefore x equals to 2. So that is the solution to this problem. I want to believe you've learned one or two things. So we are going to be meeting in the next class. So if you have not subscribed to this channel, please kindly subscribe and invite your friends to join this platform. Thanks for watching. So let us look at another example. That's example 5. Let's look at example 5. Example 5. to 5. Now solve 2 raised to the power of x equals to 3 raised to the power of x minus 1. Now look at the question we have here. Now when you look at it carefully, you see that the base are not the same thing. So now how do we solve this type of problem? 2 raised to the power of x equals to 3 raised to the power of x minus 1. Now the first thing to do is to take log of both sides. You take log of both sides. Okay, so this is going to give you log of 2 raised to the power of x equals to log of 3 raised to the power of x minus 1. Can you see that? So this log is in base 10. Now, we are going to be applying one of the laws of logarithm. Now, whenever you have log of m raised to the power of n, if it has a power like this exponential comes to this side. So it turns to n log of n. Whenever you have something like this, so you change it to this. So look at what we have here now. This is log 2 raised to the power of x. So the x will move here. The same thing also applies to this. Everything here moves here. So I have x log of 2 equals to, now when this one comes here, we have x minus 1 log of 3. Hope you get that. So from here, we can now open the brackets. Let's open this bracket. Now this log 3, we multiply 1 and we also multiply minus x. So we have x log of 2 equals to, so when you use this to multiply this, you have x log 3. Use log 3 to multiply this, that's minus log 3. Okay, so now the next thing is to collect the like terms. So this one moves to this side. So I have x log of 2 minus x log of 3 equals to minus log of 3. Hope you get that. So this one just moves here and the sign changes. So we have minus at this side. Okay, so now here you can factor out x. X is common. We have x, open bracket. When you divide this by x, you are left with log 2. Divide this by x, we have minus log of 3 equals to minus log of 3. Okay? So, another law. Now, this is the law, subtraction law. When you have log m minus log n, look at this law. This is the way you write it. You write it as log of m divided by n. So, when subtracting, you divide. When subtracting, you divide. Okay, so this is the law we are going to be applying here now. Okay, now let's do that. So that means this one is going to turn to log 2 over 3. Is that clear? All right, so now we have x log 2 over 3 is equals to minus log of 3. Okay, can you see that? So we want to make x to be the square root of the formula. So we divide both sides by the coefficient of x. Coefficient of x here is log of 2 over 3. So this one comes here. So we have x equals to minus log of 3 divided by log of 2 over 3. Okay, can you see that? So we have x equals to, now what is log of 3? So you can press your calculator and get that. It's a common number. So we have minus 0.4771. So that is log 3 over. So we need our calculator now to get this. So log of log of 2 over 3. Log of 2 over 3. So what do you have? You have minus 0.1761. So that's what we have. So now when you divide now, minus will cancel minus. So you now have 0.4771 divided by 0.1761. So what do you have? You have 2. It's going to be an approximate. So it's going to be approximately, x will be approximately 2.71. 2.71. So that is going to be the answer to that problem. So suppose this question is given to you. Now, for taking log of both sides, there will be a method mark for that. Now, another thing is you open the bracket here and then you now move down here. Okay, so now let's look at it. Here you have applied law of logarithm. You see, there's always a mark for using that principle. So for applying law of logarithm here, because you have turned this to this, there will be a method mark 1. Okay, and for making x to be the square root of the formula, there's another method mark 1. And for substituting correctly, we have M1. And for getting the answer, we have A1. So the total marks for this, we have 1, 2, 3, 4, 5. 5 marks all together. All right? I want to believe you are learning. Okay, let us look at one more question and we end the class. And let's look at another question. Let's look at another question here. Solve for x if 5 raised to the power of 2x minus 26, 5 raised to the power of x plus 25 equals to 0. Now let's solve this last question. Okay, now you have to solve for x. If 5 raised to the power of 2x minus 26, 5 raised to the power of x plus 25 equals to 0. So how do we go about this question? You see, what comes to mind is I begin to look at this exponential. Now look at what I have here. I have 5 raised to the power of x. Now begin to think of how will I express this one in terms of 5 raised to the power of x, so that I'll be able to turn 5 raised to the power of x to an alphabet, just like we have been doing. All right? So look at what I'm going to do here. This returns to 5 raised to the power of x raised to the power of 2. This and this are the same thing. I'm applying this law. Whenever you have x raised to the power of m raised to the power of n, the result is x raised to the power of mn. Right? So and mn is the same thing as nm. Multiplication is commutative. If I say 2 times 3, it's the same thing as 3 times 2, right? So I can decide to move this one outside and bring this one inside. So, right, so this equals minus 26, 5 raised to the power of x plus 25 equals to 0. Can you see that? This is the only thing that is changing. This is changing to this. So you say let m be equals to 5 raised to the power of x. Right? So since you have expressed this one in terms of 5 raised to the power of x, so you can substitute it now. So this equation turns to n raised to the power of 2. Because this now is now n. So wherever I see 5 raised to the power of x now, I put n there. So m raised to the power of 2 minus 26 n plus 25 equals to 0. Okay, so when you look at this a quadratic equation in terms of n. So we're going to solve this using any method. You can use factorization, completing the square. You can use graph, and can also use a quadratic formula. So, but let's use factorization method. Now, we look for the sum and products. Sum and products. Now, the sum of this quadratic equation is the coefficient of n here. Coefficient of n, that is minus 26. And the product is the coefficient of m squared times 25. That is going to be plus 25. Now, why am I doing all this thing? Now, I want to split this minus 26n into two parts. But there are uncountable way of doing it, but there's only one way of dividing it that is going to suit what I need it for. And that is the more reason why I have to use this approach. So you should know how to extract your sum and your products. Okay, so if we have 2 here, now it's going to be 2 times 25, right? Now, so what are you going to do with all this? Now, what you need now, you need two numbers such that when you multiply the two numbers together, you will have 25. When you add the two numbers together, you will have minus 26. So that is what I need to do now. So all those numbers must be factor of the products. So the first thing I begin to think of now, what are the factor of the product? We have 1, that is all the number that can go in 25. We also have 5. And then what else? We have 25 itself. So now how do I combine to have 26? So you see that I have 1 times, I can have 1 times 25. Let's first look at the product. Or I say 5 times 5. 5 times 5 give me 25. 1 times 25 also give me 25. So I think these are the two combinations. But now let us look at these two numbers. We have 1 and 25. We have 5 and 5. If I add this and this together, will it give me 26? No, minus 26. It will only give me plus 26.